In this episode, special guest Dr. Jonathan Lunine, distinguished American planetary scientist and physicist, joins the ongoing discussion with Shinzen Young, meditation teacher and neuroscience research consultant, and Chelsey Fasano, a Columbia University neuroscience graduate. Dr. Lunine is the David C. Duncan Professor in the Physical Sciences and chair of the Department of Astronomy at Cornell University. Dr. Lunine has published over 380 research papers and is at the forefront of research into planet formation, evolution, and habitability. Dr. Lunine's work includes the Cassini mission to Saturn, the James Webb Space Telescope, and the Juno mission to Jupiter. Dr. Lunine is a member of the National Academy of Sciences and has participated in and chaired advisory and strategic planning committees for the Academy and for NASA. In this episode, the group question the compatibility of faith and science, explore the writings of St. Thomas Aquinas and the radical theology of T.S. Eliot, and consider the controversial theories of Sir Roger Penrose. Dr. Lunine also discusses his research into life on other planets, reveals the possibility of cyanide-based life, and speculates about the role of God in the universe of the Big Bang. So without further ado, Shinzen Young, Chelsey Fasano, and Dr. Jonathan Lunine. Well, I must say I'm so delighted at this lineup today. You're, of course, Dr. Lunine, a practicing Catholic as well as a highly decorated scientist, and have spoken and written about the intersection of faith and science and the dialogue there. Such a fascinating area. And it brought to my mind one of Shinzen's most profound early influences, Father William Johnston. And I might read a little from Shinzen's book Science of Enlightenment about that influence. Like my interest in meditation, my interest in science was ignited during my years in Japan. After having lived as a monk there for several years, when I was about to return to the United States, I got together with my friend Father William Johnston, a priest living in Japan who was responsible for vastly broadening my intellectual horizons. Shinzen goes on to describe Father Johnston's excitement about recent studies that had come out, perhaps verifying or pointing to neurocorrelates of certain meditators' and contemplatives' experiences and the potential there. Shinzen continues, Father Bill's spark of excitement ignited a bonfire in my mind. If science could provide evidence to confirm one effect of meditation, perhaps it could confirm other effects. More importantly, perhaps, it could discover new things about enlightenment that none of the greatest masters in the past had known. Deep, fundamental, important things. Perhaps science could even discover things about enlightenment that would make enlightenment attainable by large masses of human beings. Perhaps science could democratize enlightenment, as it had democratized other aspects of power, comfort, and convenience. This concept utterly changed my world. So I think this dialogue between faith and reason, so fascinating, so interesting. And of course, these poles perhaps have had a love-hate relationship throughout the years. We can think of course, certain figures, Galileo, etc., perhaps on the more prickly side, but also Paul in his letter to the Romans talks about this sort of natural theology, the prospect that perhaps close attention to the physical world could even be a route to knowing God. So I think even John Paul II's 1998 papal encyclical, Fides et Ratio, Faith and Reason, calls for this recovery of what he called a profound unity of faith and reason without compromising their mutual autonomy. He was calling for that. So I think it's a very fascinating subject. And Shinzen.
Yes, I'm taking notes.
Okay. Yeah, the full
but
quote
I'm listening
actually,
also.
The full quote actually is faith. He's calling Pope John Paul II was calling for faith and philosophy to recover the profound unity which allows them to stand in harmony with their nature without compromising their mutual autonomy. So I think many ways, many directions we could go from here. But perhaps I'll hand it over to Shinzen. The echoes of Father William Johnston, I think, are certainly here.
Well, this area, science and religion, is certainly something that we could talk about to take advantage of having Jonathan with us. because that's an area where he has a lot of expertise. So certainly that's one direction we could pursue. It's not the only one that I had in mind, Jonathan, when I was thinking we'd have a chance to talk in this kind of format. The other direction that sort of interests me is how you view life, both life in the sense of embodied existence and life from the perspective of biological science, which at this point is an evolutionary synthesis that's, to me, enormously impressive and itself rapidly evolving. Sort of, how you, as someone that mounts life at a galactic or cosmic or maybe even multiverse, like life in all possible string theoretic universes, what is life big? Life seems to be very, to me, in a 21st century understanding, it seems very big. And I'm just wondering how big, how big is life? And how you would see life against the universe or multiverse picture that science speculates in cosmology. So that I'm just fascinated by what's happening in biology. And we were told by Anthony Damasio, a big figure in this field, you neuroscientists, don't think neuroscience, think biology. It's all a consequence of biology. And I've taken that to heart. So the other thing that I was just personally interested in, besides the sort of faith, philosophy, dialogue, is how you think about life as in the cosmos, and then how that might relate to embodied life and spiritual life being, I think, an important part of embodied life. So that was another thing that I sort of had in mind. Chelsey, I bet you had something.
Are we just tossing out all the options right now and then giving Dr.
I guess
Lunine
so.
like a pick your own adventure? Okay. I had a few different ideas, and some of them are related to, I know you understand physics, and so there's some theories of David Bohm, who's a physicist, and what he postulated essentially is that consciousness itself is not a property of neurology. It's not produced by neurology. It's actually beyond matter. And so there's this idea that consciousness could be something that is coming through matter rather than a product of matter. And I was wondering, I haven't had the chance to talk to a real life physicist or someone who really understands these things deeply about how plausible this really is. And, from there, if that's possible, could this consciousness be the Buddha nature or the Christ consciousness, or this sort of thing that we all talk about in different terms? Like, is there a relationship between physics and God that's direct like that? So that was one of my questions. And the other was the idea of what Evan Thompson is calling Buddhist exceptionalism is very interesting to me, that there's this idea that Buddhism and science have been constructed as a pairing that makes a lot of sense. But once you actually examine how that construction has occurred, it's really a modern phenomenon. And that in the past, Christian philosophy or Catholic philosophy and science have been constructed in the same manner. So kind of breaking down these false distinctions in my mind about which religions are compatible with science more than others, and how you view that. That's something I'm very interested to hear about from you.
Let me try to make the mistake of every interviewee and answer all your questions at once. And we'll see how that goes. So first of all, let me give a little bit of background with respect to the first question, the conflict of science and faith, or the compatibility of science and faith. I am talking to you from the university that was founded by Ezra Cornell and Andrew Dixon White. Andrew Dixon White, the first president of Cornell, was one of two historians who wrote books in the 19th century arguing that science and religion were implacable foes. Andrew Dixon White's book on the warfare between science and religion, that's not exactly the title, was not the most historically accurate book. If you read it today, it almost reads like something you would pick up at a supermarket checkout line. But it's a fast read, and it's very exciting. But it's acknowledged to be provocative rather than accurate. Nonetheless, both that book and one written a couple of decades earlier by a scholar named William Draper, are generally credited with establishing the notion that science would ultimately take over from religion, that they were in fact competitors in the same field, and that religion inevitably was going to lose. Now, it's certainly true that there have been times in the past, such as the trial of Galileo, when organized religion, institutional religion, has wandered into territory that we now recognize is more properly the purview of science. On the other hand, the Galileo affair was a very complicated one, which involved politics, poor choices on the part of Galileo of how to portray his characters, for example, and also the Roman Catholic Church's reaction to the Reformation, essentially we call it Counter-Reformation. But you have to remember, at the same time, the Catholic Church had employed mathematicians and astronomers, essentially Jesuits, to reform the calendar, which the Julian calendar was not accurate enough to maintain the coordination of the months with the seasons over a period of centuries. And so, famously, Easter was drifting out of the spring into other parts of the year. And so he had Pope Gregory had a committee which was led by a Jesuit mathematician, Christopher Clavius, which produced what we now call the Gregorian calendar, and that's the calendar that we use today. And along the way, some astronomical observations were made. And that committee essentially established what over the centuries, this is the late 1500s, so the late 16th century, over the centuries, by the 19th century, would become the Vatican Observatory, staffed by Jesuit astronomers and brothers who I've had quite a lot of interaction with, and have done not only superb science, but hold summer schools for graduate students from countries where astronomy is not so well developed. Some of those have gone on to have quite spectacular careers. So it's interesting that one of the key points in history where this quote-unquote warfare between science and religion has perhaps its headline is also the point at which the sort of a concordance of science and faith became established, and I think that's very important. My own contribution to this has been to help establish something called the Society of Catholic Scientists, which is an organization of about 1,300 scientists who are Catholic. Some are science students, most are faculty, to essentially witness to the harmony of faith and science, that these are all scientists who work in their fields of science who happen to be Catholic. And we have a website with a number of answers to questions and profiles of scientists, famous scientists who also happen to be Catholic. Now, that's the Catholic faith. That is just one faith, right? We have this incredible rainbow of faiths across the globe, and the same holds for all of them. In fact, there have been books written recently establishing that this perception that science and faith are at odds with each other is very much a Western phenomenon, almost peculiarly an American phenomenon, and that in many other parts of the world that perception is seen as kind of a surprising thing. So I think that certainly has to be borne in mind. So I'm happy to talk more about that. I'm happy to talk about some of my own scientific heroes in that regard, including Georges Lemaître, who was a Catholic priest and a famous cosmologist, and actually did an incredible amount of work in the early 20th century, some of which is not well known, some of which is very well known. He was the originator of the Big Bang model for the origin of the universe, as well as a number of other scientists who were religious and even as their profession were religious, and that I think provide a response to this perception that science and faith are in conflict. So let me move to Shinzen's question, if I can. One of my great scientific interests is in looking for life elsewhere in the universe, and my own focus as a planetary scientist is in trying to directly detect life elsewhere in our own solar system. One of the great discoveries of planetary exploration over the last, I would say 20 years now, 25 years, has been that there are places in the outer solar system around Jupiter and Saturn where there are moons that have oceans of liquid water under their surfaces. And in two cases, those oceans are really close to the surface, so that we may be able to, not too far in the future, to actually sample that material and look for evidence of life. And in another case, so that's Jupiter's moon Europa and Saturn's moon Enceladus. Enceladus is not a well-known name. It's a name out of Greek mythology. It is what it is. Because I'm trying to propose a mission to Enceladus, I wish it had a more romantic name. But
you're still working on that.
We're working on that. So we've had 2 tries, and we're going again for a 3rd try when we have our next opportunity in 2024. So that's, and then there's a 3rd moon of Saturn called Titan, which is this enormous Mercury-sized world with a dense atmosphere of nitrogen. The air pressure at the surface is 50% higher than it is at sea level on the Earth. And one of the great discoveries made by Cassini that I was privileged and fortunate enough to have participated in to a great extent is that there are seas of methane on the surface, stable seas of liquid methane, which we're still investigating today by analyzing some of the remaining Cassini data from a mission that ended in 2017. So, could there be a kind of biology that would work in liquid methane? What would the constraints be? It's extremely cold. It's 90 degrees above absolute zero. Chemical reactions are really sluggish. The kinds of chemistry that we take for granted in terrestrial biology, which of course works in liquid water, doesn't work in these methane seas. But there are other kinds of chemical bonding mechanisms that occur. There's something called hydrogen bonding, where you have a molecule that creates a kind of an electric charge on one end that's positive and negative on the other, polar molecules, and they can result in a hydrogen on the end of one molecule associating with an oxygen or a nitrogen atom on another molecule. A much weaker bond, but in those conditions, that could be as important as what we call covalent bonding in water. And an interesting fact is that because water itself as a liquid is so strongly hydrogen bonding, the oxygen on one end of the water bonds with the hydrogen on another water molecule. Other molecules don't have a chance to hydrogen bond. They're sort of cut out of the deal. But because methane is not polar as a liquid, these other molecules that might be dissolved in the methane can do hydrogen bonding, and that could dominate the equivalent of biology there. So,
and
first,
the other molecules would be what's participating in the biology.
in the biology, yeah.
And then the methane is playing the role of the solvent, the water on Earth. My
Methane.
God.
Yeah.
What would be the other molecules?
So the other molecules, so some of the things that have been investigated are polymers of, and I know this doesn't sound very palatable to terrestrial life, but polymers of hydrogen cyanide, HCN, which can essentially polymerize to form linear chains of what are called imines, IMINES. And we showed actually in a paper from here at Cornell with a quantum chemist who worked on this, that those in turn could form sheets of structures that could be the surfaces for catalytic chemistry. Another one.
Can any of those sheets create a closed two-dimensional topology, a spherical surface, and become
like a cell? So just the sheet kind of stretched the limits of the computing that we're able to do here. But there's another group proposed the idea that vinyl cyanide could actually form a spherical structure of on the order of a few tenths of a micron across, tens of nanometers across, actually a little smaller than that, and could actually be stable in liquid methane. And so these were termed adsotosomes in analogy with liposomes on the Earth, and adsote because they involve nitrogen. So the vinyl cyanide has been found in the atmosphere of Titan. The upper atmosphere of Titan, where the air is not so dense, is exposed to ultraviolet light from the sun. And so the methane, CH4, and the nitrogen that are the dominant gases react. They get broken apart by sunlight to make these very reactive fragments. And so that particular compound, along with many others, are produced. And the fate of those compounds is to form aerosols that eventually sink to the surface. So, so there's a potential for the equivalent of a vesicle that might work in liquid methane. And
I just got to ask,
yeah,
how would the information be stored? We've got DNA, and I personally think maybe a lot more than that. It's
right.
Maybe all information all the way down. In this scenario where, I mean, I never even heard of this. This is so mind-boggling. Like cyanide-based life.
Right, in liquid methane. Yeah.
In liquid methane. So
right.
I'm always asking myself, what's the information doing here? So from the viewpoint of the chemistry, where's the information?
Right. So what is the information carrying molecule? So that there have been...
Or more broadly, just where's the information? Maybe it's... Who knows?
You know, you have to ask the question, where was the information during the origin of life on Earth, right? And I'm not trying to deflect your question. I'll get to an answer in a minute. But there was a time on the early Earth when DNA did not exist, when RNA did not exist. There are precursors to those that have been proposed, like tNA, which involves the sugar threose rather than ribose. It's a little easier to make. That's been synthesized in the lab. But all of those require some pretty elaborate catalytic chemistry to purify and produce those molecules. So once upon a time, there was prebiotic chemistry on the Earth that where the information was not carried by these relatively sophisticated molecules. And I think it's fair to say that it's still a puzzle as to what was carrying that information at the time, and how did that build up to the point where things like the nucleic acid molecules could actually be concentrated enough that they would function as the information carrying molecules. So it's still a puzzle for the Earth, and we have that puzzle for Titan. So that, Shinzen, is one area where there haven't been all that terrific a set of proposals. There have been some ideas for potentially some molecules involving oxygen and nitrogen that have been proposed by some groups, but whether those could actually be synthesized or not isn't really clear. There are some interesting experiments that were done at JPL, which is this NASA lab run by Caltech, where co-crystals of ethane and some other more complex nitriles actually have formed. And maybe those co-crystals, because they are crystals, could contain that information. And
I don't know what a co-crystal is.
So a co-crystal is where you actually have two different compounds that normally exist separately from each other forming a crystal. And in this case, one of them would be ethane, which is a product of methane chemistry and would be dissolved in the methane seas. And the other could be something else. In this case, the lab work was done with benzene, which contains carbon and nitrogen. And what they found was the ethane would come out and form a structure with the benzene. So, if one could grow these, those might be the starting point for an information carrying system of some kind. But it's really, this kind of chemistry is tough because no one's really familiar with it from the point of view of the Earth. The behavior of liquid methane is so different. To some extent, things don't dissolve all that well in liquid methane. That might be an impediment to this kind of life. So, and then of course there's the problem of people getting funding to do this, right? I mean, I hate to bring it back to the real world, but it's not always easy to get funding to do laboratory experiments on life in methane liquids. But those experiments are intriguing because they do allow for compounds of these very simple molecules to come together in the form of these solids that might potentially be the starting point for carrying information, in analogy with one proposal for the origin of life on Earth, where clay minerals, the surfaces of clay minerals, provided a kind of templating surface that in effect would provide information, because the clay surfaces would restrict the number of different orientations that organic.
Oh, I hadn't thought. Of course, there's the entropy.
Yes.
That's brought in because the clay has negative entropy.
Right. I mean, it's got this definite structure to it. You can think of it in terms of more information or less entropy, and that's an old idea. I mean, it goes back 40 years now, I think.
Yeah, but I never connected the two.
Yeah.
Until you just said this. That is, wow. I'm going to think about that.
Okay, good. People have put that aside in the origin of earthly life at the moment. But so that's the story with Titan, and there is actually a mission that's being prepared to go to Titan. It happened to win out over my Enceladus proposal, but that's okay. It's a great mission, and it will go back to Titan, and it's actually a dual quadcopter. It's about a 300 kilogram mass quadcopter. Remember, Titan has a dense atmosphere, and so it'll land on Titan and then fly around to different locations and sample those sites for the early stages of what might be a kind of a Titan-based life. So there's an exotic form of life. I mean, you can go even farther, right? The Harvard physicist Lisa Randall has speculated about whether on some large scale there could be dark matter life. We think of dark matter as very diffuse, not very interactive. It provides gravity, but it doesn't interact with light, so it doesn't dissipate in any way energy. But maybe on some grand scale there could be something like that. To my way of thinking as just a boring planetary scientist, I think there's so many possibilities with normal matter, and we see around exoplanets now. There's so many planets around other stars, one planet for every star in our galaxy on average. And we're starting to see now planets that are in the habitable zone of their stars, that is where liquid water would be stable on the surface. That's an enormous potential reservoir of at least simple life. And so I think the next frontier is going to be to see, and how many of those places in our solar system and beyond life actually does occur, life forms.
Now, those habitable zones, as they're currently defined, it sounds like they're defined in terms of stable water on a surface, or
they are. Yep. And
perhaps also underneath the surface.
So,
or does it have to be on the surface to be, quote, habitable in the current definition?
So it is on the surface. And so, an alien astronomer looking at our solar system, if that alien extraterrestrial astronomer were to use the habitable zone rule strictly, they would rule out Europa and Enceladus and Titan. And so a lesson for us is not to rule out places like that. On the other hand, when you're dealing with planets around other stars, the only real method for determining whether biology is occurring on those places is to look at their spectra, to look at the light coming from their atmospheres and surfaces. And so in the case of a body like Europa or Enceladus, for example, those moons that have liquid water underneath their surfaces, you'd have a really tough time if they were around another star determining what was going on. In the case of our Enceladus and our Europa, we have an easy time, relatively speaking, because we can send spacecraft there. Cassini flew through these jets of gas and ice that were spewing out of fractures on Enceladus, coming directly from the ocean. And Cassini measured organic molecules and salts and little silica grains indicating hydrothermal chemistry. And so that's why Enceladus is so interesting, because the basic evidence that there's a habitable environment in that subterranean ocean can be sampled directly by spacecraft, and we can't do that with these extrasolar planets. So we're kind of stuck with the traditional habitable zone. But even so, I think there's going to be just an abundance of places that could host life, and it's incumbent upon us to determine, whether, first in more detail, whether they're habitable, and then whether there are even signs of biology.
So as I'm evaluating the information I'm getting, so as a cutting edge scientist in the field of astrobiology, you're saying that on the galactic scale, our galaxy, there are probably water-bearing planets on what percentage of the stars, did you say?
Yeah, so the statistics aren't really good enough to say what percentage, but one can certainly say that of the discovered extrasolar planets, there's a definite population. And now bear in mind these, because it's easier to detect planets that are closer to their parent stars rather than farther away. That sounds a little paradoxical, but the techniques by which planets are detected are indirect, and they're more sensitive when the planet's closer to the star. So these are planets that are orbiting around cool stars, M dwarfs or red dwarfs, and so their habitable zone is scrunched inward. But there seem to be a lot of Earth-sized planets around those kinds of stars detected by the Kepler mission, for example.
So you're saying that the weaker stars it seemed to have planets with stable water as a general tendency.
They have planets that are at a position where stable liquid water could exist, but we haven't, or I should say astronomy hasn't gotten to the point where spectroscopy is good enough to determine if there's stable liquid water. And
I see. It's potentially there, though.
Potentially there. And the James Webb Space Telescope, which was launched on Christmas Day of this last year, this enormous 6.5-meter space telescope that kind of unfolded like a giant origami puzzle and is now being commissioned, has the potential for detecting water. So that would be the first opportunity to actually see whether some of these objects might in fact have that water.
Water on the extrasolar candidate planets.
Exactly, yes.
And then that will give perhaps some guess as to how common that situation is in the galaxy.
Yes, and that's just the first step, and it's an incredibly difficult step, and then trying to find the signatures of biology on these worlds that are small and close to their parent stars. That would be another step further beyond the Webb telescope. I mean, this is like trying to detect a firefly next to a fully illuminated lighthouse that's tens of miles away. It's just, these are incredibly difficult problems that Giordano Bruno, who didn't have a great relationship with the Catholic Church, first articulated in one of his books. He said there must be innumerable planets around stars, but we can't see them because the light of the star drowns out the light of the planet. And it was an incredibly modern statement to make from the early 1600s, essentially.
Well, bringing it back to where we started, and a little bit relating to Chelsey's question.
Right, I haven't forgotten that question. I was going
to but the direction that you're going is it's fascinating, but it leads me to the much bigger question. Mm-hmm. Okay, we talked about the probability of terrestrial style life, I guess we would say, that's water-based. I don't know what the proper way to say that, but water-based life. Then we talked about cyanide-based life at in liquid methane close to 90 degrees above absolute zero, I think you said. But now we're thinking, where's the information and where's the metabolism possibly in this very esoteric chemistry? Mm-hmm. So then the next question is, galaxy-wise and then cosmos-wise, how big is life? How many kinds of chemistries are life, represent life? And once again, I got to ask myself, when we ask, where's the information? I think we're starting to ask the question, where's the consciousness?
Right.
Not exactly, but there's got to be some overlap between what we know about information, thanks to Shannon, and actually thanks to thermodynamics from the 1800s. What we know about information, we can quantify it with a log value. It has that math to it. Yeah. So that's got to have something to do with consciousness. And so when you turn your intellectual eye to the question of life in the multiverse, do you have any speculation as to what we could say scientifically on one hand, theologically, on the other hand?
Yeah. So what is consciousness? I mean, that is the big question.
I'm going to suggest that might be a little bit of a red herring to my thing, because it's so big. I'm more interested in, like, how big is life, and where is the role of information in just information as we would understand it, as it's stored, generated, corrupted, preserved, sort of big picture. How big is life? How many chemistries can be life? And where is the information?
Right.
Can I add on tack on to that question?
Go ahead.
People are not shaking their heads, so I'm going to do it. I guess I'm curious, Dr. Lunine, there's these really large questions about what is consciousness, and then the relationship of consciousness to life. And what I'm thinking that question relates to is this inquiry into what is it like to be these organisms you're talking about? Is there something that it's like to be them? And the idea that there might be something there, right? That it's like to be an organism that you're describing, which is wild or not. But I'm wondering what your thought process is around that as you're discovering these things, and also how your faith figures into all of this, and how you think about life and faith as you're exploring these totally out there dimensions of reality that most people never even think about much.
Sure. Okay. So let me try to approach Shinzen's question. I don't think anybody knows what the full range of chemistries might be for life, but let's assume that life is one additional step in this sort of unfolding of the self-organization of the universe. That we look at the universe, not the multiverse, but our universe to begin with. And one of the striking things about it is that it has the property that it began, if you just run the tape back, it began with a very, very low value of the global entropy compared to what it could have had. And the reason that one can make that statement actually goes back to Stephen Hawking, who had the insight that black holes have entropy, and that entropy is a function of the surface area of the black hole, not the mass. And so he and Roger Penrose both have made the point that it's more likely that you could start a universe off essentially with all, let's say, just black holes. That would be a potentially very common outcome of the birth of a universe. And that would not be a universe that would have this principle of self-organization and complexification, because the information content to begin with would be very small. It's sort of the end state of our own universe, if you want to think of it that way, leaving aside the problem of the acceleration of the universe and dark energy. So, our universe, in a sense, was primed, and I'll use that term even though it's a little teleological, but we'll get back to that in a minute. Our universe was primed to self-organize, and life on Earth is, at least as far as what we can study locally, the pinnacle of that self-organization today. But is that necessarily the ultimate pinnacle, right? Is there something beyond, and I'm totally speculating now, is there something beyond what we call carbon-based, water-based life, or life that exists in methane, whatever, that is the next level of organization beyond that? Does that have something to do with consciousness? Is there a sort of a larger scale organization of consciousness that one would say represents the next step? Because after all, there was a time in the universe when life didn't exist, when there were not enough heavy elements Stars had not manufactured enough heavy elements to produce planets, to produce enough carbon for life. There was a time before that when there was not enough any heavy elements to produce anything other than pure hydrogen helium stars that were very short-lived and that basically just exploded after a few million years, starting the process of element formation. And you go even before that, and there's a lower level of organization. So there's this kind of almost hierarchical unfolding of information content and complexity, of which, without sounding too immodest, we are at least the observable pinnacle. But are we actually the pinnacle in the cosmos?
Well, yes. And is meta life the hypothesized,
right,
next, in some sense already here, is the first question that comes to my mind.
Right. And
in fact,
mm-hmm.
Are all the levels already here in some sense? Because you referenced Sir Roger Penrose.
Sir Roger, yes.
Yeah, he has some very interesting ideas about what the Big Bang, as we are looking at it from this end, but he has a very interesting geometry.
Yes.
That, and sounds like you're familiar with that. It's pretty amazing that the human mind can think of something that abstract. But with his geometry, he makes, to my non-specialist mind, he makes a pretty compelling case that, just like T.S. Eliot said, in the end is my beginning.
Exactly. Right.
And so, Roger says in English, the universe gets so big that it can't keep time anymore.
Right. Time
and
stops.
Time does not now exist.
Right.
And that's the birth of time.
Yep.
And when we look back, we call that the Big Bang. Wow.
Yeah, his conformal cyclical universe.
Yes, that's what it's called. Exactly.
Right. Yes. Right. Yeah, it's an amazing idea. He's not very popular among his fellow cosmologists, but it's a brilliant idea. So, yes. So, what the end essentially becomes the beginning. The end is the beginning by definition in his model.
And so where is linear order, or for that matter, any order? What happened to how everyone thinks about time?
Right.
And that Eliot equated now with Christ directly. He said that. And at least the Anglican form of Christianity said, fine. He was close with the Archbishop of Canterbury. He was the only layperson that they talked to on theology. He was in good standing.
Uh-huh.
And that poem, The Four Quartets,
yes,
is the most radical Christian theology ever. He says it.
Yeah.
He says the incarnation is the intersection of time and the timeless.
And the timeless. Yeah.
And we're talking about, Sir Roger is talking about timelessness in the mind of the cosmos. He's personifying, of course, but oh my God, if that's the way things work, how does that place all this other discussion about life and self-organizing? Because it just seems to me that all those levels are probably already here. And anyway, I'm getting off topic, but
No,
I'd like to hear what you have to say about this. Really, it's very speculative, of course, but you talked about self-organizing.
Yes.
And that's an information thing.
Yes.
It brings in entropy and information. And I don't know quite where to go. I'll hand it over to you.
Well, what you just said was a lot more profound than what I'm about to say, Shinzen. So this will be anticlimactic. But I was going to say two things. One is the question of whether, in fact, the evolution of the universe, given the physical laws that we know and entropy and Shannon information theory, is actually enough to produce life. I mean, there are some, like Paul Davies, who have speculated that there's another principle that we're missing, essentially, in this process that he's written about. The other is, just to answer Chelsey's question directly, from my own faith, from a long time ago, much longer ago than T.S. Eliot. Thomas Aquinas wrote in his Compendium of Theology that the diversity of life actually expressed a certain order in creation, that it was a way of expressing the order of creation that, of course, is God's creation, the creation of the Creator. And so the more diversity, the more it expresses that order. And so in a sense, from Aquinas's point of view, we would expect to find, more and unexpected varieties of what we would call life through the cosmos, because that in effect expresses this order of the cosmos that Thomas didn't have access to a lot of what we understand today about, any of the physics or quantum mechanics or whatever. I mean, even experimental science hadn't started at that point. But that was really his insight. And where this goes with conformal cyclical cosmologies, with the Penrose idea, it's always possible that he's wrong. Of course, it's very speculative, but it's.
I think it's likely he's wrong. But
everything was likely. But
just the fact that he could be right with an idea like that.
Yeah.
Whoa.
And what's extraordinary about it is the idea that embedded within this flow of time is this ultimate timelessness that then, leads to the beginning again. And so that, I mean, it's not even circular, right? It's not a circular thing. It's a linear thing that ends by definition with the end of time and then the beginning of it again. And does life in some way persist beyond that point? Does consciousness persist beyond that point? Does it persist from one episode of that cycle, if you will, to another? I think they're extraordinary questions, but not as well stated as what Shinzen just did with T.S. Eliot's insight.
Are you saying, just from my own understanding, that part of God's nature would be to be infinite in its manifestations, in a certain sense, that there's a way in which you can think of your exploration itself into all of these infinite forms of life as an exploration into the manifest nature of Godhead, that it must be everything that we could possibly think of and more? Is that what you were kind of indicating, or is there something, a slightly different interpretation there?
So, okay, so moving, all right, so, what St. Thomas argued was anything that we would define as God, the creator of all reality. And that doesn't mean something that lights a match at the beginning in a linear way. That means something that is ontologically at the foundation of all reality, has to be infinite, has to be eternal, and by definition, therefore, could be the author of something that is, in some respects, timeless, or oscillates between something that is in time and timeless. That there is There is no barrier to that. There's no logical barrier to that. I mean, that's the best way I can address that question. And, for God to be eternal, that doesn't mean that God exists forever. That means literally that God is outside of time. And that's fine, because in Penrose's model, there is a moment when the universe is not necessarily outside of time, but becomes devoid of time at some phase in that cycle. And of course, the mind of God, if you want to think of it in some way, has already seen that. That has already happened, and has happened innumerable times. So does consciousness persist through those cycles? I think that's
from a physics point of view, does information persist through those cycles? What happens to the information? Because as I understand it, not being a physicist, but it is a central point that information is not created or destroyed. Is that still a central point, or are there paradoxes?
Well, I think there are paradoxes, and of course, entropy is something that isn't conserved. So in principle, you would, I think it's an unresolved issue as to whether you could have let's say, an infinite number of these cycles back in time and still have a finite entropy. And I don't really know the answer to that question, and I don't think Penrose does either. I think that would be a problem. So.
Well, I'm afraid our time is out. We're out of time.
Okay.
Such a wonderful discussion. Thank you so much, Dr. Lunine, for joining us. I really must petition you for a sequel at some time in the future. I know we've really barely scratched the surface. And so perhaps at a later date, we could revisit some of these themes and even go beyond them. This has been so fascinating. Thank you very much.
Well, you're welcome. I'm going to now go back and review T.S. Eliot's relationship to the Anglican Church, because that was something I've learned from Shinzen, and I fear
I check it out. Maybe it's a brain fart, but I seem to read someplace that the Archbishop liked him or something.
Well, that'll be my homework, to check that out. And I hope I didn't spend too much time on Weird Life on Titan.
Oh my God, it was so rich, man.
Okay, well, there's so many other topics. So if you want to have me back, I'm happy to come back. It would be an honor.
Well, we would be delighted. And, Steve, I'm thinking, well, Jonathan's obviously not a priest, as you erroneously thought. But maybe we could get an imam to talk about Islam and science. Oh, we got Jay just called.
Oh,
well, better late than never, I guess. Let me
Jay,
end the episode.
You missed the meeting.
Oh dear.
We're on the air.
It's not normally this chaotic, I can assure you.
This is by far the most chaotic of all of our meetings, and I think this has been going on for like a year and a half.
We're winding up. Jay, I'll call you back in a second.
That's the point. That is the point.
Okay. Exactly. Shinzen Young, Chelsey Fasano, and Dr. Jonathan Lunine, thank you very much.
A real pleasure. Thank you.
Thank you for listening to another Guru Viking podcast. For more interviews like these, as well as articles, videos, and guided meditations, visit www.guruviking.com.